Okay, so welcome to another edition of my Master of the Skies weather briefing show. Don't hesitate to click on the like button below the video if you enjoy the content of this channel, and also to click on the links in the description if you're interested in products related to better understanding the atmosphere and how to forecast the weather yourself. Okay, so in this edition, today we're going to talk about a pretty interesting topic, and that is snow that Japan tends to get during the winter time. Now, where Japan sits over the Western Pacific, they tend in the wintertime to get a lot of snow, and we're going to take a look at that topic now. Now, for some of you, you may know that actually the snow that occurs in Japan during the wintertime sometimes is known as what they call Japao, which stands for Japan snow. And basically, it's one of the most powdery type of snow you can encounter, and that has to do a lot with the atmospheric conditions that typically affect the island. And we're going to delve into that right now and also look at a recent case of very heavy snowfall having affected both islands of the main island and the northern island Hokkaido. Okay, so here is some of these incredible snowfall amounts that have occurred in early February of 2025. And you can see some of these pictures showing some of the people in the street trying to shovel all the snow out after several days of intense snowfall. You can see how the intense snowfall rates led to a lot of traffic congestion and basically the snow clearing material having a tough time to keep up with these intense snowfall rates. And you could see that the roads were pretty much impassable. Traffic came to a standstill and a lot of flights were canceled at most of the airports on the island. You could see that the cars were pretty much buried into snow, and of course it was very difficult to clear the roads right after the event occurred. And so really some incredible pictures coming out of Japan these last couple of weeks. Now, as it turns out, in terms of the amounts, they pretty much varied. Most of the heavier amounts occurred on the western coast of Japan, both on the main island and the northern island of Hokkaido, where they also had a lot of snow on the southern portion of the island. For example, on the main island in Shikawira in Gifu Prefecture State, the amount of snowfall reached about 129 centimeters, which is about 50 inches of snow or 4.2 feet of snow in a 48-hour period, basically between February 3rd and February 5th. Which constituted a record high according to the Japan Meteorological Agency. You also had very heavy snowfalls over shorter time periods. For example, over a 12-hour period, snowfall accumulated to 50 centimeters or about 19.6 inches or 1.7 feet in Toyama in the 12-hour period. Also 48 centimeters in Shikawara and 45 centimeters in Joetsu, Niigata Prefecture, in those 12-hour periods. So really pretty intense snowfalls. And there were even higher snowfalls in 12 hours, especially on the southern coast of Hokkaido Island, where they had up to basically 120 centimeters of snow in 12 hours. That's just ridiculous. 3.9 feet of snow, or 105 centimeters, or 3.5 feet of snow in Memuru, 69 centimeters of snow, 2.3 feet in Shiranuka, all located on the southern portion of Hokkaido Island. So really heavy snowfall rates, and now I'm going to try to explain to you what actually happened and why Japan tends to get some of these very heavy snowfall during the winter time on their island. So if we go back to February 3rd of this year, so we had a low pressure system forming in the Sea of Japan. It's that large body of water located between Japan and between the Eurasian continent. And you could see that you had this low pressure system right smack in the middle. And as you animate this satellite imagery here on windy.com, you can see you basically the low pressure system advected to the northeast along with the different frontal zones. You had a trailing cold front located just about here and the warm front here to the north. And as you animate it, you can see that these frontal zones basically impacted most of Japan, whether it be the main island or the northern island. Now, if we look at the radar, you could also sort of see that. Of course, radar is limited to near the land regions since you don't have radar visibility over the middle of the ocean, but you could see some of this precipitation linked to the frontal zone of the cold front and the warm front over the northern island. And as this low pressure system advected through, a lot of precipitation was associated with it. And so you could also see here more clearly with the low pressure system with the trailing cold front and the warm front, and then on the backside the occluded front. You had a huge temperature difference between the Siberian air mass, which was really cold, and the air ahead of the cold front, which is rather warm, sort of maritime tropical air, and much milder air to the south of that front. So when you get these large temperature differences between air masses, that typically favors the development of strong low pressure systems along those frontal zones. And you can see, if we take a look at what's going on here over the Eurasian continent and over Siberia, you could see you really have a large pool of very cold air this time of year where you have temperatures anywhere between -20 to -40 degrees Celsius. And whenever you have this really cold air that advex further south over the Sea of Japan or Japan, then you can really get interesting weather conditions. It's the same thing over North America with the cold pool of air over Canada a lot of times during the wintertime, and that usually will set up pretty strong low pressure systems along the frontal boundary of the polar front, separating that tropical air over the south and that very cold air up to the north. And so with that in mind, that's one of the factors that contributed to the very heavy snowfall. So this powerful low pressure system that barreled in over the Sea of Japan. Now, what's also interesting here is that another factor that was really critical was the fact that you had some topography here located on the western coast of Japan, whether it be over the southern part of the country or the central coast or even the northern coast. You have different mountain chains located right along the coastline. And so whenever you have air coming off this body of water and impinging on this topography, basically the air has to basically slide over the topography, and in doing so the air is going to cool, condense, and usually deposit precipitation on the windward side. And so that's also an aggravating factor here. And what happened in early February is that you basically have mountain change. Looking here on Google Earth, you can also see some of these mountainous areas pretty close to the western coast of Japan, and any air coming off the Sea of Japan is actually going to be forced up and over these topographical features, and that's going to squeeze out a lot of the moisture. And so that's certainly, you see here also on this conceptual model, you have the air coming off the Sea of Japan and being forced over. It wrings out the precipitation on the windward side and actually dries the air mass on the other side. And this is sort of analogous to what happens with the Föhn effect or the Chinook effect over in North America, for example, or wherever you have upslope flow that's going to wring out the precipitation, and on the leeward side, then you get this subsiding air, Föhn or Chinook air that's much drier. And so most of the precipitation in this case and in these scenarios are deposited on the windward side of these mountain chains, whereas on the other side you get usually little or no precipitation actually. And this is analogous to this Föhn effect, where this windward component of air being forced over the topography, saturating the air and leading to a lot of precipitation. And on the other side, you have subsiding, warming air that will usually tend to dry out the air mass very quickly. And so you have to sort of consider the air as sort of a fluid, and you can sort of see that here where you have some upward clouds along a mountain barrier with some precipitation probably ongoing, and on the other side it sort of overspills, and as the air sinks it's actually drying. And so you really see this in action in terms of the effect that actually occurs. Now, looking at what happened here, you can sort of pick this out looking at the satellite imagery. So you can see the cold front impinging on the western coast of Japan, and as it does so, you can see even in the infrared imagery that a lot of the clouds are confined to the western coast, whereas on the eastern coast you get much less clouds since a lot of this is subsiding air. And so you end up having even some clear skies there, whereas on the windward side you keep getting more clouds and more precipitation. So you could also see that on the radar. You could see the impinging cold front coming in, and you could see that most of the precipitation is confined to the western coast where the air is rising over the topography. And then Tokyo, for example, on the leeward side actually got very little precipitation along with this system, as you're getting more of that subsiding air, and most of the lift is being forced on the windward side or on the southern side of Hokkaido, as the flow was actually pivoting to the south over this area. So that was one of the second factor. And a third factor, and not the least, was what we called the sea effect or lake effect snow bands that actually occurred. And just to take a look at what actually occurs with these, what we call lake effect or sea effect snows, is that when you have a large body of water that's relatively warm and then you have very cold air flowing on top of that, typically that will lead to very unstable conditions at low levels, since cold air over warm air is really unstable, and so that will tend to favor cumulus cloud development, vertical cloud development, and the higher the cumulus go, the better you have a chance of actually precipitating out of those cumulus clouds. And so that will tend to lead with these sort of lake effect snow band or sea effect snow bands that are actually oriented parallel to the low level flow and actually push these low level bands over the adjusting land regions and will deposit all the precipitation there, and even more so if you have an upslope component, as you see here. And so usually you need a temperature difference of about 12 to 13 degrees Celsius between the surface water temperature and the overlying air. And then, of course, the more the difference is pronounced between the ocean or the sea or the lake and the overlying air, the greater that difference in temperature is, the more unstable the air will become, and the more apt you're going to be in producing rather heavy lake effect snow bands. And you can see here an example over Michigan where you have air coming out of Canada, which is really continental polar air, very cold, flowing over the relatively warm lake waters, and you can see these lake effect precipitation bands setting up over northern Michigan, and those are typically what we call these lake effect, or in the case of Japan, these sea effect snow bands. Now, you could also see it in this animation. You could sort of see that when you animate it, where you sort of see these cloud bands that set up, and with the cold air over the Sea of Japan will basically produce these lake effect snow bands and deposit the snow. And looking at what actually happened for this case, if we go back to essentially, you go back to the 3rd of February, you could sort of see all this cold air over Siberia, even at low levels around 1,500 meters or 5,000 feet. All this cold air basically ended up spilling over the Sea of Japan as this potent low pressure system developed and moved to the northeast. And so you're basically advecting all that cold air from the overlying Siberian region and advecting it over the Sea of Japan, and really increasing the instability at low levels over that body of water. And this is essentially what happens when you look at this conceptual model. You have these very cold winds off the continent that blow over this relatively warm body of water and basically set up these lake effect cloud bands that get bigger and bigger as the fetch or the residence time of the cold air remains over the water, and by the time it gets over to the coast of Japan, these clouds and cumulus and showers have developed sufficiently to dump pretty heavy amounts along the western coast of Japan, amplified by the lifting effect that's produced and aided by that topography. And we can sort of see that also here. If we look at what happened actually behind the cold front on the 4th of February, you can really distinctly see these sea effect cloud bands really oriented parallel to the atmospheric flow. And as we animate this, you can really see them move and get advected towards Japan and the western coast. Even in the infrared imagery, you can see that this continues through most of the day of the 4th of February and actually continued on the 5th and even on the 6th. And if you take a look at the corresponding radar imagery, you could sort of see this as well. As you get closer to the landmass, you could see these lake effect snow bands really oriented parallel pretty much to the flow and impinging on the western coast of Japan, and aided also by the upslope of that topography along the western coast. So basically, quite interesting factors, actually 3 distinct factors that helped really produce these very extremely heavy snowfalls. And you also had some aggravating factors for this case and in Japan in general, since you look at basically the width of the Sea of Japan, it's really, really very wide. If we take out of a measurement here, you're basically about 900 kilometers of sea coverage. And so any air mass coming off of the continent has ample residence time over this body of water to absorb all the moisture, and in this unstable condition will tend to produce quite large cumulus clouds and then dump all that precipitation along the western coast. If you compare that to the Great Lakes in North America, while they all are quite wide, and most of them do produce lake effect snow bands, some of them very heavy during the winter time, as some of you may of course know. Even if you take the largest width along, for example, Lake Michigan, that is only 480 kilometers approximately. Now that's very wide, but that's only half as wide as the Sea of Japan. So you can see how these lake effect snow bands become even quite larger over the Sea of Japan when weather conditions are right. And finally, another aggravating factor is the fact that the ocean current that actually flows along the western coast of Japan is relatively warm. It's actually what we call the Tsushima warm current, actually coming in from the tropical Pacific, moving up to the north, part of it branching out over the eastern coast. That's the Kuroshio current. And then on this western branch is the Tsushima current. And so since you're amplifying the warmth of the surface of the water, then you're basically increasing the instability between the air temperature above and the ocean temperature below. And so the greater that temperature difference, the bigger the cumulus will be able to get, and the more apt you will be to produce some heavy snowfall. As a matter of fact, some of these conditions are so unstable that you can even produce thunderstorms in these scenarios, low-type thunderstorms with lightning and thunder associated with the snow, but that we typically call thunder snows. And those kind of thunder snows will actually produce some of the heaviest snowfalls that you can ever encounter. So that is pretty impressive indeed. And just to show you how that looks like, sorry, let me load that again. If we take a look at the ocean currents that actually flow next to Japan, you can see the Kuroshio current here on the eastern coast, and then you get an inkling, an idea of this Kuroshio current, which is also coming in from the south, and that actually flows along the western coasts. And as a consequence of that, you're basically getting some either warm sea surface temperatures associated with that. You could see temperatures of about 10 to 12 degrees Celsius, that's about 50 to 54 degrees Fahrenheit. And so those are relatively warm waters during the wintertime, especially if you get very cold air aloft over the top of that. For example, if you take a look at the temperatures at around 1,500 meters or 5,000 feet, you could see that if you have a flow off the continent, you may get like -6 degrees. But if you look at some of these colder air here to the further west, if you get -10, -15, or even -20 degrees to flow on top of that, you can imagine the unstable conditions that you will produce over the Sea of Japan waters, and that will certainly favor the production of the sea effect snow bands that will later deposit all their snow along the western coast. So basically cold air with a warm current underneath, or end up with this really pretty intense snow effect machine that it's in play, and coupled with this topography on the western coast of Japan is capable of producing extremely heavy snowfall rates and amounts. So there you go. That's all I have for today. I hope you enjoyed it. Don't forget to click on the subscribe button if you enjoy this content and this channel. And again, if you enjoy learning more about how the atmosphere works or learning how to forecast the weather yourself, don't hesitate to check out some of my links in the description. And with that, hope you enjoyed it, and I'll see you next time.